What if I told you the most important security upgrade of the decade already happened and almost nobody noticed? While you were reading headlines about artificial intelligence, 3 of the biggest technology companies on Earth were quietly rewriting the mathematical foundation that protects nearly everything you do online. Cloudflare did it, Google did it, Apple did it. They did it because of a threat that sounds like science fiction, but is already, right now, actively being used against you. Here's the part that should genuinely unsettle you. Somewhere out there, right now, someone is copying encrypted data that belongs to governments, banks, hospitals, and ordinary people like you. They are not trying to break it. Not yet. They cannot. The encryption protecting that data is still, for now, unbreakable with the technology that exists today. So instead, they are simply storing it, filing it away, waiting. Because they know that at some point in the coming years, a machine will exist that can rip that encryption apart the way a can opener rips through a tin can. This strategy already has a name inside the cybersecurity world. It is called Harvest Now, Decrypt Later, and it is the single biggest reason why Cloudflare, Google, and Apple have spent the last 2 years quietly rebuilding the locks that protect the internet. To understand why this matters, you first need to understand what is actually holding the digital world together. Every time you check your bank balance, send a text message, log into your email, or buy something online, your device and the server on the other end perform a kind of secret handshake. They use mathematical problems that are, for a normal computer, essentially impossible to solve within a human lifetime. Multiplying 2 massive prime numbers together is fast. Taking that giant result and figuring out which 2 primes were multiplied to create it is agonizingly slow, even for the most powerful supercomputers on the planet. That imbalance, easy in one direction and brutally hard in the other, is the entire foundation of modern encryption. It is why your credit card number does not get stolen every time you shop online. It is why your private messages stay private. It is why entire economies can run on digital trust. Quantum computers threaten to collapse that imbalance completely. A quantum computer does not think the way a normal computer does. Instead of processing information as simple ones and zeros, one at a time, it uses quantum bits, or qubits, which can exist in multiple states simultaneously. Without diving into a physics lecture, the practical result is this. A sufficiently powerful quantum computer running a specific algorithm known as Shor's algorithm could theoretically tear through the exact mathematical problems that today's encryption depends on. Problems that would take a classical computer longer than the age of the universe to solve could, in theory, be solved by a mature quantum computer in a matter of hours or even minutes. That is not a small improvement. That is an extinction event for the encryption standards the entire internet currently relies on. Now, before you panic and start unplugging your router, here is the important nuance. Nobody has built a quantum computer capable of doing this yet. The machines that exist today, even the most advanced ones from companies like Google and IBM, are nowhere near powerful enough or stable enough to break real-world encryption. This is not happening tomorrow. But that is exactly where the Harvest Now, Decrypt Later problem becomes so dangerous. The attackers do not need the quantum computer to exist today. They only need it to exist eventually, and they need to have already captured your encrypted data before that day arrives. For information that only matters for a few weeks, this is a non-issue. But think about the categories of data that need to stay secret for decades. Government intelligence, health records, legal documents, trade secrets, long-term financial infrastructure, cryptographic keys used to secure entire networks. If any of that gets harvested today and decrypted 10 years from now, the damage is exactly as real as if it had been stolen today. This is the exact reasoning that pushed the National Institute of Standards and Technology, the American government body responsible for setting cryptographic standards, to issue a clear and urgent directive. Organizations around the world need to upgrade their cryptographic algorithms before the year 2030, or risk having their most sensitive data exposed once sufficiently powerful quantum computers arrive. Some engineers in the security world refer to that theoretical breaking point as Qday. The day a quantum computer becomes capable of shattering the encryption the modern internet depends on. Nobody knows exactly when Qday will happen. Some experts think it is decades away. Others believe recent breakthroughs in quantum hardware and error correction have moved that timeline dramatically closer. But almost nobody in serious cryptography circles is arguing that it will never happen. The only real debate is about timing, not inevitability. And this is exactly why Cloudflare, Google, and Apple did not wait around for a definitive answer. Each of these companies sits at a different, critical layer of how the internet actually functions, and each one has been rebuilding its cryptographic foundations for years, often with far less fanfare than the moment truly deserves. Let's start with Cloudflare, because in many ways, Cloudflare has moved the fastest and the furthest of the 3. If you are not familiar with what Cloudflare actually does, think of it as one of the largest connective tissues of the modern internet. A massive percentage of global web traffic passes through Cloudflare's network before it ever reaches its final destination. That means Cloudflare is in an unusually powerful position. When Cloudflare upgrades its encryption, it does not just protect one company. It protects a staggering portion of the traffic flowing across the entire internet all at once. By early 2026, Cloudflare had already reached a milestone that would have sounded almost impossible just a few years earlier. More than 2/3 of the browser traffic flowing through Cloudflare's global network was already being protected using post-quantum encryption. Read that number again. 2/3. Not a small pilot program, not a handful of enterprise clients testing something experimental in a lab. The majority of real-world traffic moving through one of the largest networks on the internet had already transitioned to quantum-resistant protection. Cloudflare did not stop at basic web traffic either. The company extended post-quantum protection across its entire Cloudflare One platform, which handles what is known as Secure Access Service Edge, or SASE, technology used by businesses to secure their internal networks, remote employees, and cloud infrastructure. This expansion covered everything from the virtual private network technology used by remote workers to the wide area networking systems that connect entire corporate offices together. In practical terms, Cloudflare built what it describes as the first complete SASE platform in the world to support modern post-quantum encryption across its entire stack, not just in isolated pieces. Here is a detail that deserves special attention because it reveals just how seriously the entire industry is taking this threat. Cloudflare's original internal target date for achieving full post-quantum security was tied to that same broad 2030 deadline set by government cryptography standards. But in April of 2026, Cloudflare made a decision that quietly signaled just how urgent this problem has become. The company moved its own internal target forward, aiming for full post-quantum security by 2029 instead. Why the change? Cloudflare pointed directly to new research breakthroughs coming out of Google's quantum computing efforts. In other words, one company's accelerating progress on quantum hardware and quantum algorithms directly forced another massive company to accelerate its own defensive timeline. That is not abstract theory. That is a real, measurable ripple effect happening across the tech industry right now, largely outside the public eye. Cloudflare also made real progress on one of the two fundamental pillars of encryption that need to be upgraded for full quantum resistance. Encryption relies on two separate cryptographic building blocks working together. The first is called key agreement, which is essentially the process two devices use to securely agree on a shared secret before they start communicating. The second is called digital signatures, which are used to verify that the party you're communicating with is actually who they claim to be, rather than an imposter intercepting the conversation. Upgrading key agreement to be quantum resistant has proven to be the easier of the two problems, and that is where most of the industry's early progress is concentrated. Upgrading digital signatures to be quantum resistant is significantly harder, and it is where the real technical battle is still being fought. Cloudflare has already deployed support for a post-quantum digital signature algorithm known as ML-DSA, a standard formally recognized by the National Institute of Standards and Technology. Right now, that support primarily covers the connection between Cloudflare's network and the origin servers it protects, but it represents real, deployed progress on the harder half of the quantum security puzzle, not just theoretical planning documents sitting in a drawer somewhere. Now let's talk about Google, because Google's story adds a layer of urgency that is honestly a little unsettling once you understand what triggered it. Google has technically been working on post-quantum cryptography since 2016, quietly researching and testing early quantum-resistant algorithms years before most of the public had ever heard the phrase post-quantum cryptography. For a long time, this work moved at a steady, methodical pace, the kind of careful long-term research you would expect from a company thinking decades ahead. Chrome, the world's most widely used web browser, began experimenting with early post-quantum key exchange algorithms years ago, giving Google valuable real-world data on how these new, more complex cryptographic methods actually perform when deployed at a massive global scale. But then, in March of 2026, something changed. Google made an announcement that effectively compressed its own internal timeline for the entire quantum-safe transition. The company set a new target date of 2029, aligning almost exactly with Cloudflare's revised timeline, and it explicitly cited accelerating advances in quantum computing hardware, improvements in quantum error correction, and updated theoretical estimates around how quickly quantum machines could eventually factor the large numbers that traditional encryption depends on. Here's the detail that should really grab your attention. Alongside that announcement, Google's own research division published a separate and deeply significant disclosure. According to that research, future quantum computers might be able to break elliptic curve cryptography, the exact system currently protecting the vast majority of cryptocurrency wallets, secure website connections, and digital signatures across the internet, using dramatically fewer qubits and quantum logic gates than researchers had previously believed necessary. In plain language, Google's own scientists found evidence suggesting the quantum threat might arrive with less computing power than the industry had been planning around. That is not a marketing announcement designed to sell a product. That is a technical research finding from one of the most advanced quantum computing teams on the planet, and it is exactly the kind of discovery that makes cryptographers around the world sit up a little straighter in their chairs. Google is not only accelerating its timeline internally. The company is actively pushing post-quantum protection outward into the products billions of people use every single day. Android, the operating system running on the majority of smartphones worldwide, is being updated to include post-quantum digital signature protection built on that same ML-DSA standard used by Cloudflare. Google Cloud has been rolling out post-quantum capabilities for enterprise customers, allowing businesses to begin their own quantum-safe transitions using Google's infrastructure rather than having to build the technology entirely on their own. And Chrome, the browser sitting on more devices than any other software product in history, has been quietly working on solving one of the trickiest technical problems in this entire transition, a problem most people have genuinely never thought about. Here is that problem, explained simply. Post-quantum cryptographic keys and digital certificates are physically larger than the classical ones currently used across the internet. That might sound like a minor technical footnote, but at the scale Google operates, it is a genuine engineering challenge. Every single website you visit using a secure connection presents a digital certificate to prove its identity. And those certificates get logged in massive public systems known as certificate transparency logs, designed to prevent fraud and impersonation. If every certificate on the internet suddenly became several times larger because of quantum-resistant cryptography, it could meaningfully slow down page loading times and strain the bandwidth of networks all over the world. Google's answer to this problem is a new initiative called PLANTS, which stands for PKI, Logs, and Tree Signatures. Rather than simply swapping in larger post-quantum certificates and accepting the performance hit, Google is developing an entirely new certificate architecture based on something called Merkle tree certificates, designed specifically to deliver quantum-resistant security without dragging down the speed of the modern web. This is not a small patch. Google's own security team has described this transition as less like a routine software update and more like a full digital transformation initiative, one that requires fundamentally new architecture purpose built for the quantum era, rather than just retrofitting old systems with new math. Before we move to Apple, it is worth understanding where these specific algorithms, ML-KEM and ML-DSA, actually came from, because the backstory explains why three fiercely competitive tech giants all landed on the exact same math. For years, the National Institute of Standards and Technology ran a global multi-round competition, inviting cryptographers, universities, and research labs from around the world to submit candidate algorithms designed to resist quantum attacks. Dozens of proposals were submitted, and each one was picked apart, attacked, and stress-tested by independent researchers hunting for hidden weaknesses. Some candidates that looked promising early on were later broken entirely and eliminated from consideration, which is exactly the point of running such a long adversarial public process rather than simply picking an algorithm behind closed doors. The survivors of that process, the algorithms that withstood years of attempted attacks from the best cryptographers on the planet, were formally standardized. ML-KEM became the winning approach for secure key exchange, and ML-DSA became the winning approach for digital signatures. This is precisely why Cloudflare, Google, and Apple all converged on the same underlying technology, despite being direct competitors in almost every other part of their business. Nobody had to negotiate a shared standard. The open, transparent, adversarial vetting process did that work for them, and the result is a rare moment of quiet, unspoken cooperation across an industry that usually guards its technology closely. Now let's turn to Apple, because in many ways, Apple was actually the first of these three giants to make quantum-safe cryptography a headline moment, even if most people did not fully grasp the significance at the time. Back in 2024, Apple introduced something called PQ3, a new cryptographic protocol built specifically to protect iMessage, one of the most widely used private messaging platforms in the world. What made PQ3 genuinely groundbreaking was not just that it added post-quantum protection. Plenty of companies could have done that in a fairly basic way. What made PQ3 stand out was how thoroughly Apple implemented it. Security researchers use a tiered system to describe how well a messaging protocol protects against future quantum threats. At what is described as level 2 security, a protocol adds post-quantum protection only during that very first moment when two devices establish a secure connection. That is helpful, but it leaves a serious gap. If an attacker manages to compromise the encryption keys later in a long-running conversation, all subsequent messages remain vulnerable because the post-quantum protection was never reapplied after that initial handshake. Apple decided that was not good enough. PQ3 was engineered to reach what the company calls Level 3 security, a tier where post-quantum protection is applied not just once at the very beginning of a conversation, but continuously throughout it. Every 50 message exchanges, Apple's system automatically mixes in a brand new post-quantum cryptographic key, essentially refreshing the lock on the conversation over and over again as it continues. This means that even if an attacker somehow managed to compromise a key at some point during a long-running conversation, the ongoing rekeying process would automatically heal that vulnerability and restore security moving forward, without requiring the user to do anything at all. At the time it launched, Apple described PQ3 as having the strongest security properties of any large-scale messaging protocol in the world, and independent cryptography researchers who studied the design largely validated that claim, publishing formal mathematical proofs, analyzing exactly how and why the protocol holds up against theoretical quantum attacks. Apple's more recent move, however, might actually be the more important story, even though it received far less mainstream attention. In May of 2026, Apple published something that companies protecting billions of devices almost never do voluntarily. The company released the source code for Core Crypto, the low-level cryptographic library that quietly powers security across virtually every layer of Apple's software ecosystem, including the security framework, CryptoKit, and Common Crypto, the underlying tools responsible for encryption, secure hashing, random number generation, and digital signatures across iPhones, iPads, and Macs. Buried inside that release were Apple's actual working implementations of both major post-quantum algorithms selected by government standards bodies, ML-KEM for secure key exchange and ML-DSA for digital signatures, the exact same signature standard that both Cloudflare and Google have also adopted. This detail matters more than it might initially seem. When three of the largest technology companies on Earth independently converge on the exact same standardized algorithms, it is a strong signal that the industry has moved past the experimental phase and into genuine, coordinated real-world deployment. But Apple did not stop at simply releasing the code. Alongside it, the company published detailed information about its formal verification process, an advanced mathematical technique used to rigorously prove that cryptographic code behaves exactly as intended, with no hidden bugs or subtle flaws that could quietly undermine the entire system. Apple explained that it built a custom verification approach because existing industry tools were not sufficient for the scale and complexity of its requirements, given that Core Crypto needs to function reliably across an enormous range of Apple hardware, including many different generations of custom Apple-designed chips. By making this work public, Apple is inviting the broader cryptographic research community to scrutinize its implementation, stress test it, and identify any weaknesses before they can ever be exploited in the real world. That kind of transparency is genuinely rare for a company known for operating behind closed doors, and it signals just how seriously Apple is treating the long-term stakes of this transition. So here is the bigger picture forming underneath all three of these individual stories. Cloudflare, Google, and Apple did not coordinate these moves through some secret alliance. They arrived at strikingly similar conclusions independently, based on the same underlying mathematics, the same emerging quantum research, and the same government guidance from bodies like the National Institute of Standards and Technology. All three companies converged on the same core post-quantum algorithms. All three companies accelerated their internal timelines specifically because of new quantum computing research breakthroughs, rather than simply following a fixed calendar deadline set years in advance. And all three companies are now actively pushing this protection outward, embedding it directly into the products and infrastructure that billions of ordinary people rely on every single day, whether or not those people ever notice it happening. This raises an obvious and important question. If you're not a cybersecurity engineer, not running a data center, and not personally responsible for protecting a company's network, does any of this actually affect you? The honest answer is yes, in ways that are easy to overlook. Every time you send a message on your iPhone, browse a website protected by Cloudflare, or use a Google service, you're increasingly benefiting from these quantum-resistant upgrades without lifting a finger. This is precisely how the best security transitions are supposed to work. The protection gets built directly into the infrastructure itself, quietly and automatically, rather than requiring every single person on Earth to understand quantum physics and manually configure their own devices. You do not need to know what ML-KEM stands for to benefit from it. You just need the companies building your technology to take the threat seriously, and right now, the biggest ones clearly are. That said, there's a meaningful difference between consumer protection and the responsibilities facing businesses, governments, and organizations that handle especially sensitive long-term data. If you run a company that stores information, needing to remain confidential for many years into the future, this is not a topic you can afford to quietly ignore while waiting for the technology to simply arrive on its own. Security researchers and standards organizations are increasingly urging businesses to begin what is often called crypto agility, building systems flexible enough to swap out cryptographic algorithms relatively quickly as new standards continue to emerge, rather than being locked into rigid, outdated systems that are painful and expensive to update. Given that Cloudflare, Google, and Apple have all moved their internal target dates to 2029, a full year ahead of the original 2030 government guidance, that should serve as a fairly clear signal about how seriously the organizations closest to this problem are actually treating the timeline. It is also worth pausing to appreciate just how enormous an engineering undertaking this entire transition actually represents. This is not comparable to a routine software patch pushed out overnight to fix a minor bug. Post-quantum cryptography algorithms are structurally different from the classical algorithms that have quietly underpinned the internet for decades. They often require larger keys, larger digital certificates, and different mathematical operations entirely. And rolling all of that out at a truly global scale, without breaking compatibility for older devices or meaningfully slowing down performance for billions of daily users, is an extraordinarily difficult engineering problem. Google's entire Plants initiative exists specifically to solve just one narrow slice of that much larger challenge: the sheer size of quantum-resistant certificates within the web's existing certificate transparency infrastructure. Multiply that same category of challenge across every layer of internet infrastructure worldwide, from banking systems to healthcare networks to government communications, and you begin to grasp the true scale of what Cloudflare, Google, and Apple have already quietly accomplished, and how much difficult work still genuinely remains ahead of them. There is one more layer to this story that rarely gets the attention it deserves, and it concerns trust itself. For decades, the entire digital world has operated on a kind of invisible faith that the encryption protecting our data is simply permanently unbreakable. Most people never think about it at all, in the same way most people never think about the structural engineering holding up the bridge they drive across every single day. Quantum computing represents the first genuinely credible, mathematically grounded threat to that foundational assumption in the entire history of modern computing. And the fact that Cloudflare, Google, and Apple responded not with panic or empty marketing promises, but with real, deployed, independently verifiable engineering work is honestly one of the more reassuring developments in recent cybersecurity history, even though almost nobody has been talking about it in those terms. So the next time you send an iMessage, load a website, or open an app built on Google's cloud infrastructure, understand that you're quietly walking across a bridge that has already been reinforced for a storm that has not fully arrived yet. The companies building that bridge did not wait for the storm to show up on the horizon before reacting. They started reinforcing the foundation years in advance, based on credible research, expert consensus, and a level of caution that is honestly rare to witness in an industry more often associated with moving fast and worrying about the consequences later. Cloudflare, Google, and Apple already went quantum safe. They did it quietly, they did it methodically, and in doing so, they gave the rest of us a genuine head start on a threat that most people do not even know exists yet. The real question now is not whether the rest of the world eventually catches up to this transition. It is simply how much time we actually have left before the harvesting that is already quietly happening becomes the decrypting that changes everything. And based on everything Cloudflare, Google, and Apple have already built, tested, published, and deployed, it is clear they are not planning to wait around and find out the hard way.